Behind me is Lake Carl Blackwell. Oklahoma State University takes its water from this reservoir. But you don't really take water from nature, you just borrow it for a while. All the water that has ever been or ever will be on planet Earth is here right now, circulating in the water cycle. The water cycle doesn't have a beginning or an end. Plants borrow moisture from the soil, use a little, and pass most of it to the atmosphere as water vapor. Movement of water vapor from plants is called transpiration. Water vapor leaving the surface of ponded water is called evaporation. We sometimes lump the two together and call it evapotranspiration. The sun's energy pumps a tremendous amount of water into the atmosphere through evapotranspiration. But air can only hold so much water, especially in the colder, thinner upper atmosphere. So water vapor condenses into water droplets and ice crystals and falls back to Earth in the form of rain, sleet, snow, and hail. Some of the moisture precipitating on Earth is absorbed by plants. Some soaks deep into the soil and becomes groundwater. Groundwater can come back to the surface in seeps, springs, and the base flow of streams. We can also borrow groundwater by drilling wells into the saturated subsoil. Some of the precipitation moves across the surface of the Earth as runoff. Runoff collects in rills, runnels, and rivulets, eventually gathering into creeks and rivers. The area gathering runoff for a stream is called a watershed. Rivers flow into the ocean, and the ocean is never full. Man can put a dam in a stream, block the flow, and store water in a reservoir. Back in the 1930s, the federal government did just that. They put a dam on Stillwater Creek, creating the reservoir we call Lake Carl Blackwell. Lake Carl Blackwell is an upper watershed lake. It collects water from the furthest upstream portion of the Stillwater Creek watershed. Since the lake is at the top of the watershed, it receives runoff close to where precipitation hits the ground. Precipitation falls on the lake surface, and the reservoir receives runoff from pasture, prairie, and scrubby woods. In the late 1940s, the university tapped into Lake Carl Blackwell by laying a 6-mile-long pipeline to this water treatment plant. When it was built, this was perhaps the most advanced water treatment facility in the United States. The old plant has been updated through the years, but it's still an impressive conventional water treatment facility. Water is made fit for human consumption through chemical and physical treatment, disinfected and pumped to the OSU campus, where it is used for drinking, cooking, cleaning, recreation, irrigation, and removing waste from the system. Wastewater from OSU enters the City of Stillwater sewer system. Wastewater from both campus and the city end up here, the City of Stillwater Wastewater Treatment Plant. Wastewater is biologically treated and disinfected to remove organic matter, plant nutrients, harmful organisms, and chemical pollutants, making it safe to discharge to the natural environment. So, where does the water go once it leaves the Stillwater treatment plant? The treatment plant discharges to Brush Creek. The mixture of treated effluent and creek water flows a short distance to Stillwater Creek. Stillwater Creek flows southeast and empties into the Cimarron River near Ripley, Oklahoma. The Cimarron River flows into Keystone Reservoir. The Arkansas River also flows into Keystone Reservoir. Water flowing out of Keystone Dam enters the McClellan-Kerr Arkansas River Navigation System, which is managed by the U.S. Army Corps of Engineers. The McClellan-Kerr Navigation System stretches from Tulsa to Fort Smith and across the entire state of Arkansas. The river is impounded in a series of reservoirs, both large and small, to provide sufficient depth for barge travel to move up and down the river. The navigation system controls how much water flows from the Arkansas River into the Mississippi River, and whether it flows down the Arkansas or the White River Channel. The Corps of Engineers also controls water flowing down the Mississippi River. Through a system of levees, dams, and diversions, part of the flow is sent down the Gulf of Mexico down the Atchafalaya Channel. The rest flows down the Mississippi Channel and enters the Gulf through the Mississippi Delta below New Orleans. You may have noticed from the time runoff enters Lake Carl Blackwell until it flows to the Gulf of Mexico, its passage is completely controlled by man, but that doesn't mean it's not circular. How does water fill Lake Carl Blackwell? Rainfall from local evapotranspiration provides some water, but most of the water that falls in the watershed comes from far away. A large amount of water evaporates off the Gulf. Some of it's carried north by southerly winds. A relatively small amount of this water falls on this little watershed, fills Lake Carl Blackwell, and provides the lifeblood of Oklahoma State University. From Lake Carl Blackwell, through the OSU campus, down the Mississippi to the Gulf of Mexico, and back again. Just a tiny part of the worldwide water cycle which makes life on Earth possible.